In this problem, it says a survey of 18 randomly selected households in Wynot, North Carolina. Yeah, that's actually a place, by the way. Showed that the mean household income in 2018 was 53,568 with a standard deviation of 7,528. Construct a confidence interval about the population mean household income in Wynot, North Carolina. Well, first thing to notice here is that there is no level of confidence given. So we default to 95% level of confidence, which means that we have an alpha of 0.05, alpha over 2.025, but you'll see what happens. Also, sigma is unknown. We're given a standard deviation, however, nowhere does it say that this is a population standard deviation. If you don't see the word population there, or you don't see a sigma equals, you assume that whatever you get, it's S, which is the sample standard deviation. So the correct sampling distribution for this one is the t distribution. In Excel, the correct function, as I stated previously, is t.inv.2t, and then it's just alpha comma new. One strange thing that I find in Excel is that we have the two-tailed function and we have the one-tailed function. And I wish they had done that with the norm.inv.s function, because it would just make things a lot easier when we transition into the t distribution, because a t distribution has one for one tail and two tail. So just know this, that we don't have to split alpha into the two tails, because this function automatically does it for us. In other words, we don't have to find alpha over 2, because when you just put alpha in here, it automatically will give us alpha over 2, and it gives us the positive result. And again, it's alpha comma new, so that's why on the spreadsheet I just had that new function there, the n minus 1. So for this problem, here's what we have. We have x bar, or the sample mean, is 53,568. S, or my sample standard deviation, is 7,528. N is equal to 18. There are 18 households surveyed. New is equal to 18 minus 1, or 17. My level of confidence is 0.95. Alpha equals 0.05. Alpha over 2 equals 0.025. But if we're not given our population standard deviation, as I said, the alpha over 2 part of this is not necessary. Yeah, we'll keep it on the spreadsheet, but it's just not necessary. And then t sub alpha over 2 is equal to t dot inv, that 2t of whatever my alpha is, comma, whatever new is, which was 17, and that's approximately equal to 2.1098155578. And as I have said earlier, because sigma is not given to us in the problem, we use the formula E equals t sub alpha over 2 times s over the square root of n. And notice this is the square root of n, not the square root of new here. The only time we use new is when we're working with the t function itself on the spreadsheet. So this is over, as I said, the square root of n. If I plug the parameters into that, I would have E equals 2.1098 times the 7528 over the square root of 18, which comes out to be approximately 3,743.59. The confidence interval is, we take the sample mean that we were given in the problem, which is 53,568, and from that we subtract the 3,743. It's less than mu, and then we do the thing with addition, and we get the mean household income, the population mean income. We can be 95% confident that it falls between $49,824.41 and $57,311.59. And here is the conclusion. We can conclude that with a 95% level of confidence, the population mean household income in Wynot, North Carolina, is between these two numbers. Let's go to spreadsheet mode and see how we would pop that in on a spreadsheet. Let's put these numbers in. We have 53,568 for my X bar. N was only 18. It'll automatically populate new my S or sigma, and in this case it's S, was 7,528. Level of confidence, that was not given to us, so we defaulted to the 0.95 or 95% level of confidence. And we have alpha is equal to 0.05, and alpha over 2, even though we don't need it, is 0.025. Because sigma is not known, I'm going to populate this with different information. This will be equal to, and I just go over here to the sigma or S, the standard deviation. It doesn't change, it's just that on the right-hand panel, the one in red, we call it an S rather than a sigma. My T sub alpha over 2, here's where that new function comes in handy. That will equal T dot inv dot, right here we have 2T. Let's see, the first thing it's asking for is the probability, and remember we just use alpha, comma, new, and that's right up here. It's in cell B5, and I close this, and this function automatically gives me the positive value, and it's positive 2.1 blah blah blah, same thing I had on the problem page. And now I do the E calculation, which is just as easy as doing it over here with sigma known. It's just we have different numbers. Equals T sub alpha over 2 times S divided by square root SQRT open parenthesis of N, close parenthesis, press enter, and there we have that 3,743.58-ish number. In this cell, I'm going to take E, I'm going to subtract it from X bar, and in this cell, I am going to take E and add it to X bar, equals X bar minus E, and we have equals X bar plus E, and there I have the confidence interval. Because this one is in dollars, you probably would round down to the penny unless the problem specifically says otherwise, but I'm going to say it's between 49,824 and 41 cents, and over here $57,311.59. So this one had a lot of little quirks to it. Remember, we didn't have a confidence level given nor a level of significance, so we defaulted to the 0.95. Also, sigma was not known, but S was known, or the sample standard deviation, so we just used that, and that forced us to use the t distribution as the correct sampling distribution. The E calculation, pretty simple. And then we just subtract it from X bar and add it to X bar. Let's take a look at problem number 7. A survey of 39 randomly selected new textbooks was conducted to determine price information. The prices for the textbooks went from $79.53 to $227.99, with a mean price of $129.98. With a 0.01 level of significance, construct a confidence interval about the mean population price of textbooks. Well, let's go over a few known things. For this problem, there is no level of confidence given. However, we are given a level of significance. Well, the level of significance is the complement of my level of confidence. What that means is if we have a 0.01 level of significance, I have a 0.99 level of confidence. In other words, level of significance is the same thing as your alpha value. This means that alpha is equal to 0.01 and the level of confidence is 99% or 0.99. Now notice that this problem does not have a population standard deviation, nor does it have a sample standard deviation. So what do we do? The only thing we can do is read into the problem and come up with an estimate for my standard deviation. And it's a very rough estimate, but we use it when we know some information and not other information. If you notice, the problem does say the prices range from $79.53 to $227.99. In a case such as this, we use something called the range rule of thumb to approximate the value for the standard deviation. The formula to do this is very, very simple. Basically, we subtract the smaller value in the range from the larger value in that range of prices that we do have. We get that result and divide that result by 4. Why 4? It doesn't really matter. We just divide by 4. So, in other words, an approximation for my standard deviation is the larger value minus the smaller value divided by 4. For this problem, it's 227.99 minus 79.53 over 4. That gives me an S of approximately 37.115 or $37.11.5. Being that we do not have a population standard deviation, we must use the t distribution in this case. And if you notice, we are given a number of textbooks that we surveyed, which was 39. We have an X bar, or my sample mean, of $129.98. We have an approximation for my sample standard deviation of $37.11.5. We have n equal to 39, and since we're using the t distribution, we need to find nu, which is 39 minus 1, or 38. with a level of confidence of 0.99. That means that my alpha is 0.01, which was actually given to us in the problem, and alpha over 2 is 0.005, but because we're using the t.inv.2t function, we do not necessarily need that alpha over 2 is 0.005. So t sub alpha over 2 will equal t.inv.2t of 0.01 comma 38, and it's approximately 2.7115. And just like all other confidence interval problems, we have to find E. And if you remember the formula for E, t sub alpha over 2 times S, or any approximation that I get for S, divided by the square root of N. And in this case, it comes out to be approximately 16.12. So since that's E, we subtract that value from my sample mean, and we add that value to my sample mean. We get that the confidence interval is $113.86 is less than mu, which is less than $146.10. Which means we can be 99% confident that the population mean price of textbooks is somewhere between $113.86 and $146.10. Let's pop this on a spreadsheet. Here I have a spreadsheet that's set up specifically for when we're looking for a confidence interval and we have to use the range rule of thumb. I have X bar in here. I have N already here. This is taken directly from the problem. You can refer back to the problem. Remember, nu is just N minus 1, so that we'll just type in the formula. E, we click on whatever N is, and then we subtract 1 and press enter. I have my maximums and minimums switch, so let me fix that. We have a maximum data value of 227.99 and a minimum data value of $79.53. My level of confidence is 0.99. I know that they gave us alpha, but I always type in the level of confidence and I let the spreadsheet itself do the rest of the work. So alpha is equal to 1 minus whatever my level of confidence is. And alpha over 2, that just equals my alpha divided by 2. But remember, when we're using the range rule of thumb, the sampling distribution is the t-distribution, which means that we don't necessarily need the alpha over 2. It's calculated for us. To get my estimate of S using the RRT, or range rule of thumb, I type in equals, open parenthesis, I take my maximum data value. From that I subtract my minimum data value. In other words, the range of prices. And I close my parenthesis, divided by 4, and enter. There we have that 37.115. To get t sub alpha over 2, we have equals t dot inv dot 2t of probability, that's what I call alpha, if you remember, comma, nu, or my degrees of freedom. And then I close my parenthesis and press enter. And there we have the 2.711 number. And now I calculate E. This is just as easy as everything that I did before. Equal t sub alpha over 2 times whatever approximation I have for S. And I divide it by the square root, which remember is SQRT, of N. And close my parenthesis, press enter. And that's where I got that 16.12 number. It's really 16.115 to 1099, but who cares? All I do from here is I take my X bar value and I subtract E, that goes on the left side, and X bar value plus E, that goes on the right hand side, equals X bar minus E equals X bar plus E. Here I have the numbers that basically I had before. This means that we can be 99% confident that the population mean price for textbooks is somewhere between $113.86 and $146.10 when I round this number here.